Hello, everyone. It's great to see you all. I think I'm the last speaker for today for this workshop. I'm very honored to be here with you. Thank you very much for inviting me as a speaker. Many distinguished guests made great presentations, and based on their presentations, I can figure out that I understand that how my presentation will be. How important my presentation will be because it is about the emissions calculation system of Korea. Today, I'm going to make presentation on the Korean National Emissions Inventory and the emissions calculation system. And I'm going to brief on the results of a recent emissions inventory. When we are sick, we need to go to hospital or clinic, okay, to get diagnosis and get some treatment. Regarding the air pollutant issue, for diagnosis of this problem, we have two ways for diagnosis. One of them is related to observation, and another way is about air pollutant emissions. Observation is important, and another important one is air pollutant emissions. To find a solution to deal with this problem, we need to have a good calculation system. Okay, we started to calculate the air pollutant emissions since 1999. We have about 20 years of history under 13 major categories, and there are 9 air pollutants being calculated. And these data are utilized for various purposes, for mainly research purposes. For instance, to forecast the emissions trend. So based on the analyzed results, this data is used as the core data for policymaking. Regarding air pollutant emission calculation system, we have CAPS system, Clean Air Policy Support System. We collect about 300 data sets. And in addition to this, we have real-time monitoring devices attached to every chimney. And based on the collected data, we issue annual reports so that the policymakers can refer to the reports for their work. And we also collect data on activities, and we convert the data into dB, and we verify data as well. And in the final stage, we also verify emissions. So data conversion and data verification and emission verification. In these three parts, we have made great improvements. Regarding the calculation of emissions, we calculate emissions according to the law. We have a special act on fine dust reduction and management and Clean Air Conservation Act. As mentioned earlier, we monitor 9 pollutants, as you can see on the slide. And under 13 first level categories, actually we have almost 600 the bottom level categories. Regarding emission estimation method, here's a brief explanation. First, point sources. Amount of fuel consumption by the oil, coal, LPG at facility. So it's, as you can see on the formula over here, activity data and emissions factor are used, and we apply the efficiency of the preventive facilities. And we have TMS, it's a real-time monitoring device. Actually, the real-time monitoring device takes priorities. Regarding mobile sources, broad and calculation population and VKT, these are used as well as EF to calculate the emissions. As for area sources, as you can see on the familiar emission factor activity data, for instance, number of fires and the reduction efficiency, these are used to for calculation. Now, as I mentioned earlier, efficiency of preventive facilities are being applied at the moment, which is not included in the slide. Because if a operator has a preventive facility, they can dramatically reduce the emissions. That is why we consider that, the factor. And emissions factors, we have about 30,000 factors for the calculation. The factors developed here in Korea, actually we have about 6,000 emission factors, and the rest about 20,000 factors, emission factors, are from the US EPA or other international organizations. We are going to develop more factors, emission factors in Korea, in consideration of the unique environment, natural environment here in Korea. So I have explained how the emissions can be calculated. So we have point source, mobile sources, and the area sources. Okay, regarding the point source, we should calculate the emissions from each business sites. And bottom-up TMS data is mainly used. And for mobile sources, we can divide it into road and non-road. So vehicle populations, vehicle age distribution, VKT, vehicle kilometer traveled, BMT, road types are used, considered. And for non-road equipment population, ship call, aircraft LTO, these are used. Then now results of air pollutant emissions in 2018. We used various data. We have approximately 60,000 the business sites. And regarding vehicles, about 2.3 million vehicles, the data from these vehicles were used. And the aircraft LTO was about 890,000. These are the basic data. Regarding PM 2.0, fugitive dust, okay, PM, it is from mainly fugitive dust, and NOx, it is mainly from non-road transport and road transport, as you can see on the graph. Okay, here it is showing the spatial data for each air pollutant. Regarding the PM 2.5, most emissions of PM 2.0 mainly were from the factories and NOx from urban areas, and ammonia, NH3, were mainly from the livestock facilities or agricultural facilities. Regarding the ammonia, okay, the measures to reduce the ammonia is now one of the core, the approaches here in Korea. So the emissions data is quite different from metropolitan, between metropolitan area and non-metropolitan area. So the changes compared to 2018. Regarding the emissions of air pollutants, Korean government think that, okay, the air pollutants is just like live animals. We should continue our efforts to improve the total amount of emissions. And the basic data and the results of the calculations can be shared, of course, with those. We will welcome your feedback. You may access to our website as well to see the basic data regarding the calculated the emissions. We have English version and the Chinese version as well. You may refer to those data. Thank you very much.